Welcome to Windows Networking CS288W. This is Module 6. I'm instructor Robert McMillen. And tonight we're going to be talking about storage. So storage is something we covered in previous classes, but we certainly have not covered it in the way we're going to do it in this particular lesson. We're going to talk about ISCSI services, target, initiator. We're going to talk a little bit about clustering and SAN versus NAS, which is really confusing to a lot of people. MBR versus GPT when you go to format a drive. We're going to talk a little bit about RAID, although in previous classes that has been mostly covered. And we're going to talk about Multipath I/O, which is something that we could use when we are doing clustering and ISCSI work. And then we're going to do a demo of the lab for Lab 6 and actually do an ISCSI target and an ISCSI initiator using your Windows Server 2012 virtual machines, which is going to be really cool. I think you're going to get a lot out of that. So let's talk about storage. Storage refers to disk storage as opposed to memory, which refers to RAM. There are many new options in Server 2012, and we're going to discuss some of those. So storage no longer needs to be inside the physical server to be a drive letter. So traditionally, you've seen your drive letter, your C, your E, your F, G, whatever it is, and even your DVD, which is typically a D drive, is going to be on the inside of your server. But in this particular case, it could be outside your server like we're going to do in our lab, but it shows up as a drive letter on the inside of your server. SANs and NAS are two completely different things, which we're going to talk about in more depth coming up. And then clustering, which allows for multiple servers to be added to the same storage space, which can really help for redundancy. And you can access your storage either in Server Manager or Computer Management. So that's new to Server 2012. Before, you can only get to it by Computer Management, but now you can actually get to it through Server Manager as well, which shows a slightly different view of the same exact thing. ISCSI services, Internet Small Computer Systems Interface is what ISCSI stands for. It's storage that you can access over an Ethernet cable using TCP/IP. Once the storage is attached, you can give it a drive letter. And Server 2012 adds a new feature that allows a server to be either an initiator or a target. And I'll tell you what the difference is coming up. So, storage you can access over an Ethernet cable using TCP/IP. So basically what that means is if you have a storage area network device that is connected to your switch using an Ethernet cable, you can connect to that storage over the internet. So whereas before you would connect to it using a USB cable, you could connect to it using a fiber cable, a Scuzzy cable, all these different things, but iSCSI allows you to use an Ethernet. So it's made up of two different pieces, the iSCSI product. You have the iSCSI target and the iSCSI initiator. So an iSCSI target is the storage device itself. So this is where the data is being stored. We're going to connect to this. This is the target. You can now use a Windows 2012 server to be the storage device of another 2012 server. So we're going to actually do an example of this, which will make a lot more sense. So you want to load up a 2012 server with many hard drives, and you can create one or more partitions. So whatever your target server is going to have a lot of hard drives, a lot of storage, so you can connect to it. You install the iSCSI target role to set it up. So just like the DNS role, the DHCP role, the iSCSI target role is a role that you will use to set this all up so you can connect to it. Set up security if desired. So when you do set up the iSCSI, you can lock it down to say, okay, only this particular server can connect to me. So if anybody else tries to, I'm going to ignore it. You can also say, okay, I want authentication and encryption and things like that. Or you can just ignore all that altogether and just say, anybody can connect to it if they want to. I'm not going to put any kind of security on it. Of course, you probably wouldn't want to do that, as it's not the most secure way of doing it. But for this particular lesson, we're going to do it that way, just for speed and things like that. We can do the additional security at another time. So the iSCSI initiator, this is the other side of the ball. So the target was the thing we're connecting to. This is the thing we're connecting from. So the computer that connects to the iSCSI target is called the initiator. Traditional use was to connect to a SAN, which stands for Storage Area Network. It's just a bank of hard drives. But now the iSCSI target server can be the SAN instead, which can save a lot of money. So if your company's ever purchased a SAN before, they're typically anywhere from $10,000 to $100,000, and sometimes even more than that. And it's just very expensive to have. A lot of big companies like IBM and now Lenovo, of course, HP, Dell, they all create these SANs, these storage area network, and all they are is just a big old box of hard drives. But now you can do it on the server. So what you want to do is you want to run the iSCSI initiator service and tell it what IP the target is on. Then you connect to the target, and the storage shows up in disk management in the server manager. Then you bring the partition online by right-clicking on it, and you format the drive and assign it a letter. And then you're connecting to the target from your initiator computer. So let's change gears just a little bit here and talk about failover clustering. So failover clustering is a role you can add in Server Manager. It allows more than one server to have access to the same data resource at the same time. So the reason you want to do this is if one server fails, the resource is available using another computer. So let's picture in your mind here for a second, you've got your storage area network, which is just your bank of drives, whether that's a Windows server or an actual SAN you buy from a company. And you can use more than one server to connect to that same storage area network. So if one server goes down, the other server automatically picks up the slack and starts feeding the data out to the clients without them even realizing what happened. So you create a cluster after installing the cluster role, and then you create a common name for both servers that will respond in case one server goes down. So if you have server 1 and server 2, then what you'll do is you'll maybe create a server 3, for instance, and server 1 and server 2 will both respond to the name server 3. You have to set up the cluster storage properly on both, or both servers will freeze up when trying to access the data at the same time. So when you set up clustering, if it's not done properly, then what will happen is the storage won't realize that both servers are allowed to access the data at the same time, and it won't hand off the data properly. And then, and I've seen this happen several times, then the servers just both completely freeze up as they both try to access the same data at the same time. This can result in data loss. You'll have to restore from backup. You may even have to restore the cluster computers themselves. Let's talk about SAN versus NAS for a minute. These are both different types of storage devices, disk storage devices. And it's really easy to confuse them. They both provide additional storage for the network. So if you are running out of places to put your data, then SAN and NAS can both help. They both can provide security if you want them to, and they can both provide encryption if you want them to. There's new devices that will do either SAN or NAS depending on how you set them up, which makes it even more confusing. So a SAN, a storage area network, is storage that you connect directly to your server, which we'll be doing tonight. It has no operating system, so it cannot run on its own. It cannot run file serving or applications or anything else like that. It has to connect to a server. It requires it to be connected to a server like our Windows 2012 servers in order to work. An iSCSI target can be a SAN, or you can buy a dedicated SAN device from Lenovo, HP, Dell, and more, as I mentioned earlier. A NAS is different. It's network attached storage. This device has its own operating system, so it can operate completely on its own. It does not need to connect to another server in order to provide additional storage. Typically it runs Linux on there, but some do contain a special version of Windows. It's self-contained. It has its own user database with usernames and passwords. It's not affiliated with Active Directory. However, there are some LDAP connectors which allow you to pass on the username and password to Active Directory should you choose. You map drive shares like any other file server, but you don't create drive letters as you do in disk management with the SAN. They are typically less expensive, run on Linux, and they can be kind of buggy. So the software that runs these, it's not always all that reliable, and they put them on really inexpensive hardware sometimes, unless you buy a higher-end version. You can get a SAN for as cheap as $100 or as much as thousands of dollars. Of course, the lower-end ones aren't going to be that great. Now we have to add confusion with the hybrid SAN/NAS. So some devices have all the built-in operating systems like a NAS does, but can be used as a SAN, so you can ignore that operating system and just connect it as a SAN, such as an iSCSI, if you set it up that way. So I've created a link to a QNAP device where you can learn more, but this QNAP device can either be a NAS or it can be a SAN. It just depends on which option you choose in the website when you set it up. So in the back of this device, you'll see an Ethernet port, so you can set it up for iSCSI. You'll also see a USB drive. You'll see an eSATA connection. It's all these different ways of connecting this thing up. So it's up to you, how you want it to be. A SAN, a NAS, a USB storage device, an eSATA storage device, a FireWire storage device, whatever it is that you want. It's all in the back of this device. All right, so when you go to format your hard drive, you have two options. You have a master boot record and you have a GPT. So let's talk about the MBR, master boot record, which, by the way, has more than one meaning. MBR could mean some other things as well. But in this case, when you go to format, this is one of your options. A master boot record type of formatted drive, it can be the file that uses to point the way to Windows during boot. So this is the other definition of it. It can be the file that uses to point the way to Windows during boot. Basically, it says, hey, here's where the Windows files are. So that's what a master boot record was traditionally named. Its legacy and tops out at 2 terabytes because it's based on older technology. So when they came up with a master boot record type of formatting for a hard drive, they never thought anybody would need more than 2 terabytes, so they just maxed it out at 2 terabytes. GPT, however, is different. It stands for GUID Partition Table. This is newer, and it allows you to go to partition sizes so large that nobody's really manufactured drives or boxes big enough to contain it. So you can go into the exabytes and the petabytes, way beyond what we currently are even capable of putting together. So this is what you'll use when you create new large partitions in disk management. You can convert MBR to GPT. So if you accidentally you created an MBR partition that's 2 terabytes or less, and you're like, hey, I want to create a GPT part, I want to make it a GPT instead. You can certainly convert that if you want to. Are there advantages to one over the other? Well, speed-wise, there's really not. GPT has, of course, the ability to have a much larger partition, but MBR does not. However, some operating systems don't work with MBR because they just weren't designed. Don't work with GPT because they just weren't designed for it. They're just older operating systems, and you'll have to create 2 terabyte or smaller partitions because they're not capable of doing it. However, Windows 2003 and newer are all capable of GPT. So how do we connect to our outside storage? So let's say you have a SAN, a storage area network, and you want to connect your server to it. So what physical mediums are there out there to connect to your box of hard drives from your server? So one, of course, is fiber. Fiber is going to be super fast, and you can also connect it to multiple different ones all at once if you have a fiber switch, which is similar to an Ethernet switch. It's just all fiber connections instead of Ethernet connections. Or what I should say, Cat5 or Cat6 type connections. Then you have the iSCSI, which is your basic Cat 5, 6, 7, 8 on up that you can connect to a switch or connect directly to the SAN itself. Then you have Scuzzy, which is the old-fashioned one. This is a cable that has a whole bunch of pins on it, and there was Scuzzy 1, Scuzzy 2, Scuzzy 3. By the time they got to around Scuzzy 3 or 4, they just pretty much retired the whole technology. However, there are still some devices out there that are Scuzzy. SAS is a newer technology, and it's just a very, sort of a rectangle type of connection, and it snaps in and locks in place so you can't accidentally pull it out. It has speeds of around 6 gigabits per second, so that's, of course, a lot faster than iSCSI, which would only be, typically 1 gigabit, although iSCSI now has faster connections at 10 gigabits. So SAS will either have to increase its speed or it's going to be replaced by 10 gigabit iSCSI in the near future. Then, of course, you have a direct cable, which is really old. If you remember the old Apple days before they had Ethernet ports on them, you could connect an Apple cable and then you could copy files back and forth that way. So that is a valid way of copying data. It's just not used very much. RAID, of course, we've all heard about RAID before. It stands for Redundant Array of Inexpensive Disks. And Server 2012 offers some new RAID options, which we're not going to really get into in this class, but you should just be aware that there are some new RAID options in 2012. They do treat RAID differently. They call it by some new terminology and things like that than they did in 2008. And RAID can be used on any multi-disk storage device, such as our iSCSI. Multipath I/O has been around for a while, but it hasn't been used all that much. It's used for path redundancy. The I/O is the input-output, is what that stands for. It's a feature you install in Server Manager, so it's if you go to Add Roles and Features, then it's just one of the features that's there. It allows you to connect to a partition from a single device from more than one connection. So let's say your server has 4 network cards in them, and you're going to connect to an iSCSI device, and each of those network cards are 1 gigabit. And your maybe your connection on your iSCSI is 10 gigabit. Well, if you are going to connect your iSCSI into a 10 gig port, but you only have 1 gig ports besides that, then this is a great case for using Multipath I/O. So you plug your 4 1 gig connections into the switch and your 1 10 gig iSCSI connection, and now it allows you to communicate at 4 gigs because those 4 1 gig connections all sort of bind together in a multipath, and it allows you to send 4 times as much as if you had it with only 1 connection. However, you have to install this. It doesn't just work this way. You actually have to install it, configure it, and sometimes you need a third-party driver for it. It doesn't just the drivers don't always come with Windows. So we talked about different types of storage, iSCSI, we talked about clustering, SAN versus NAS, MBR versus GPT, RAID, and Multipath. So let's get into our lab. So you're going to need your DC01 and your support server. So in this lab, you'll need to add more storage to DC01 because you're running out of space. This is a scenario that we're going to have. But you need to use the extra capacity of support server to get it. Server 2012 is a new option for iSCSI storage where you can use the storage of one server as a drive letter on another server the same way a server can be used using a SAN. So we're turning on our support server, and let's start by creating a folder on support server right in the root of our C drive called iSCSI target. So let's see, here we go, our support server. Let's log in. And let's go to Add Roles and Features. All right, under our roles, we'll have to get there. There we go. We're going to expand File and Storage Services and expand File and iSCSI Services. Then we're going to choose just the iSCSI target server. It'll go ahead and add the features. Don't worry about this other one here. Go ahead and click Next, click Install. All right, let's go ahead and go to our C drive and create our folder. Right in the root of the C drive, new folder, and we're going to call it iSCSI target. And we're just about done here, so that's good. Okay, success. Very good. Now on the left-hand side, click on File and Storage Services. Let's go ahead and expand that. There we go. Now we're going to click this little link here. It says to create an iSCSI virtual disk. Click here. Okay, so we'll go ahead and click that. Okay, now we're getting close. All right, so let's go to the type a custom path and go to Browse, iSCSI target, select folder. Go ahead and do a screenshot of this right here for our first deliverable, and we'll click Next. All right, now we're going to name this ISCSI target. Don't have to put a description, but you certainly can. Shows our path. Let's click next. And we're just going to do this, since this is just a scenario here, we're just going to do 1 gigabyte. We don't need to use a lot of storage space here. We don't want to accidentally empty out this whole thing. And so just put 1 gigabyte. If you can also, just for fun, take a look and see what the other ones are. But that's all we're going to need. All right, now we'll go ahead and click next. New ISCSI target. Next. And once again, we'll call our name ISCSI target. Okay, one was the virtual disk name, and the other was the target name and access. We're just going to call it the same thing just for simplicity, but that's up to you. Click Add to specify the ISCSI initiators that will access this virtual disk. Let's click Add, and now we're going to stop. So now we're going to go to our other server, our DCO1. Let's go ahead and log in. And let's go to Tools and go to ISCSI Initiator. It'll say, hey, do you want to turn this thing on? Yes, I do. Let's go ahead and put in the target our IP address for support server. All right, we'll choose Quick Connect in a little bit, but for now, we're going to want to go to the Configuration tab and copy the initiator name. All right, now we're back to support server, and we're back to our add box. All right, and we're going to browse to DCO1, or just type DCO1 and click Check Names. Click OK. Automatically fills it in. Click OK, and boom, look at that. Sees our ID. Now, just for fun, let's just go ahead and pull up Notepad and paste in what we did earlier and just make sure those numbers match. And they do, exactly. So it definitely picked up the right number. So we'll go ahead and get rid of that. Go ahead and click Next. Now, here's where you can add in authentication. We're not going to do that, but you certainly can. This is the challenge type of authentication protocol. So we hit Apply, and it's thinking really hard. It's completed. It's good. Click Close. All right, it says that it found it, but it's not yet quite connected. So let's go back to our DCO1, go back to our target, and choose Quick Connect. Oh, look at that. Found it right away. Done. If you do this out of order, then it just doesn't work right. So try to do it in order that I just said. All right, so now that we have this all connected, we should be able to see this drive in our computer management. So in DCO1, let's go ahead and go to Tools in our Server Manager and go to Computer Management. Now let's go to Disk Management. And look at that. There's our 1 gigabyte partition. So right-click on that and choose Online. And got to give it a minute here. Initialize the disk. It says, hey, do you want to do a master boot record or do you want to do a GPT? At this size, it really doesn't matter. So you can choose either one. It doesn't matter to me. Let's go ahead and click OK. It's not over 2 terabytes, right? So now it says we have a partition that is unallocated. So let's choose a new volume. All right, and you can choose the default E drive, or you can choose a different drive letter, whatever it is that you want. It doesn't really matter to me. Just go ahead and click Next. And format, quick format, that's good. And finish. All right, so there's our E drive. And it is completely empty, but we can certainly add a file if we want. Just right-click on there, choose New, Text File. There we are. So don't forget to follow all the lab instructions as far as what you need to do for your screenshots. And we have now finished connecting DCO1 to support server. And we now have our ISCSI target and initiator all set up. So we've got our lab reflection just like usual. What did you learn? Did you have any problems? What does the term ISCSI mean? Not just the definition of ISCSI, but actually what does it mean? So you can look that up. Then there's a scenario here saying your advisor has decided to use a SAN made by HP instead of the ISCSI target built into Server 2012. He's requested redundancy. Explain Microsoft clustering and how it can be used to assist with this concern. Well, I did talk a little bit about clustering earlier. I'm sure you can come up with a couple of paragraphs if you do a little research on that, and that will work well for you. So that is Module 6 and Lab 6. Good luck with that, and certainly let me know if you have any problems.